So this next section is really going to tie into stuff that we did earlier, and it's the quadratic formula. And so we spent a ton of time factoring, solving equations involving factoring, and trying to get those solutions. And so now that we've got a better hand with radicals, we can go over what the quadratic formula is. So if we have a quadratic equation, so that's some number times x squared, some number times x, possibly a constant equals 0, instead of sitting there and trying to factor, because not everything will, we can instead use this quadratic formula. And so the solutions to this equation just depend on these values of a, b, and c. And so the solutions are given by this lovely formula here. So you can kind of hum it to the tune of Pop Goes the Weasel. That seems to be a nice way to remember it. So the solutions to the equation are negative b plus or minus the square root of b squared minus 4ac all over 2a. And so you're going to use this so much, eventually it just kind of becomes second nature. But this formula instead will help us solve any quadratic equation. And so you can see we have a square root here. It's very possible that we can have complex numbers as solutions to these equations. So all we're going to do is we're going to just try a ton of examples. I'm going to go through 3, but you're going to have a lot more in your homework that you have to do. But the biggest thing you need going back up here is before you pick off the values of a, b, and c to plug in, you need a 0 on this side of the equation. So you might have to do a lot of algebra first before you get a 0 on the right-hand side. So for this first one, it's already given to us, we have equals 0. So I immediately can pick off our values of a, b, and c. And this is why we like to put it in this specific order, because immediately now I know a is the value in front of x squared, it's 1. B is the value attached to x, and the signs are important. So the value of b is negative 8, and then the value of c is 15. So based on these values, I immediately know the solution to this equation. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. Because then from here, it's just simplification. So we have negative 8, that becomes positive 8. And then plus or minus this lovely square root. Negative 8 squared is positive 64. 4 times 1 times 5 ends up giving us negative 60. And then this thing is divided by 2. So this gives us 8 plus or minus the square root of 4 over 2. And then the square root of 4 is really nice. It's 8 plus or minus 2 over 2. Okay. Now both of these we can actually simplify. So I'm going to go way up here to do that. So for one solution, we'll have 8 plus 2 over 2. And for the other solution, we have 8 minus 2 over 2. So that plus minus that we have gives us both solutions. Because remember, it's x squared. We can have 2 solutions to it. And so for the first one, 8 plus 2 is 10 over 2. And then 8 minus 2 is 6 over 2. So we get 2 values that solve this equation, 5 and 3. Now really this one we did not need to use this quadratic formula for. So instead, what I can do is show you why factoring is so much nicer. Because for this one, it took a lot to get down to that final answer, but it actually factors really nicely. So to make the first terms x squared, we need an x and an x. To get to 15, we need a 5 and a 3. They have to be the same sign because it's plus 15, but it's minus in the middle. So this factors nicely into x minus 5 times x minus 3. Then we would set each of these equal to 0. And for this one, add the 5 over. For the second one, add the 3 over. So you get the same solutions, but in 3 steps as opposed to this entire long radical. So that's why factoring is really nice when we can do it. The problem is we just can't always do it. And these next 2 are going to be prime examples of that. So we're going to see we get some nasty square roots, and there's no way we'd be able to factor an expression like this. So looking at this from the get-go, though, I have a bit of an issue because I have my terms on both sides, and I don't have a 0 here. So what I need to do is I need to move everything to one side. Before I pick off those values of a, b, and c. So in this case, we've got 2x squared plus 3x equals 1. To move that to the other side, I would just go ahead and subtract it. So we get 2x squared plus 3x minus 1 equals 0. And now at this point, I can go ahead and say that my a is 2, my b is 3, and my c value is negative 1. So again, you have to have it equal 0 in order to be able to apply this formula. But now that we have these values, we immediately know our solutions. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have our solutions. We just need to simplify. So this gives us negative 3 plus or minus the square root of 9. And then negative 4 times 2 times negative 1 gives us plus 8. And then we have 4 in the bottom. So this is negative 3 plus or minus the square root of 17 over 4. And then root 17 does not simplify. So this is about all I can do with it. If you end up with a radical that you can simplify, you do need to go ahead and simplify it as much as possible. So I got one more example, and it's quite a doozy because we definitely do not even have an x squared term yet, and we also do not have 0 on one side. So in order to be able to get it into that right form, I'm going to have to FOIL all of this, and then I need to move everything to one side. So I'm going to start with the foiling on the left hand. We have 2x times 8x, that gives us 16x squared. The outer term is 2x times negative 4, so negative 8x. The inner, negative 1 times negative 8, gives us negative 8x. And then the last is negative 1, negative 4, gives us a positive 4. And that equals negative 1. So combining these on this side, this is x squared, or 16x squared minus 16x plus 4 equals negative 1. And then again, I need to get a 0, so let's add the 1 to both sides. And that gives us 16x squared minus 16x plus 5 equals 0. Now we are at a point that we have it in that right form. We have it equals 0. So my value of A is positive 16. Value of B is negative 16. Value of C is positive 5. So we got some big numbers to go through with our solutions. So our solutions are negative b plus or minus the square root of b squared minus 4ac all over 2a. And now it's a game of simplification. So negative 16 gives us positive 16. If you do negative 16 times itself, it gives us positive 256. And then 4 times 16 times 5 gives us minus 320, and then divided by 32. So at this point, maybe you notice you've got one number minus something bigger. So 256 minus 320 gives us negative 64 underneath our radical. And again, anytime I have a negative sign, I immediately need to turn it into an imaginary number. So this is the square root of 64 times I over 32. And then we just have more simplification because we can actually do the square root of 64. It is 16 plus or minus 8I over 32. And now this is also not fully simplified. So what I'm going to do, because we have this addition, let's take each piece and divide it by that 32. So it's 16 over 32 plus or minus 8 over 32I. And then if you simplify that, 32 divided by 16 is 2. So this simplifies nicely to 1/2. And then both of these are divisible by 4. So that simplifies to 1/4 I. So again, gotta simplify it as much as you possibly can. You might still be stuck with radicals and these kind of things, but it does give us just kind of a foolproof way. This method is never going to fail us like factoring can. So all the stuff we learned at the beginning, you can also solve those equations going through the quadratic formula instead.